Hello, dear students. Welcome to Shiksha Guru's Academy. Today, we will discuss one of the most important conversion in organic chemistry, which is very, very important for your JEE and NEET preparation. Okay, it is our question. It is a propene treated with HBr in the presence of peroxide and sunlight. First of all, what is a propene? We know. Here it is. It is a propene molecule. It is treated with HBr in the presence of peroxide. We know addition of HBr on alkene in presence of peroxide, sunlight produces anti-Markovnikov product. Therefore, we will get product. What is anti-Markovnikov product? Reaction follows free radical mechanism. Here it is H plus and Br minus. But in the presence of peroxide, it follows free radical mechanism. In the first step, bromine radical will attach on primary carbon. Therefore, it will produce secondary radical. यहाँ पर H प्लस अटैच होगा, मीन्स जिस कार्बन पे कम हाइड्रोजन है वह पर H प्लस अटैच हो रहा है. अल्टीमेटली जिस कार्बन पे ज्यादा हाइड्रोजन एटम है वह पर Br माइनस अटैच हो रहा है. इट इज एंटी मार्कोनिको प्रोडक्ट. वी आर गेटिंग alkyl halide. It is bromopropane. It is treated with sodium in the presence of ether. Alkyl halide react with sodium in presence of ether. The reaction is Wood's reaction. In our JEE and NEET syllabus, alkyl halide and sodium के साथ one of the famous reactions, that is Wood's reaction. What is Wood's reaction? Alkyl halide react with sodium in the presence of dry ether, produces alkane having double number of carbon atoms. Actually, mechanism is uncertain. What is exact mechanism? We don't know. Maybe it follows free radical mechanism, maybe follows ionic mechanism. That's why generally we will consider both. Therefore, we are getting N-hexane. What will happen? Simple. Between carbon-bromine bond get dissociation, just follows free radical mechanism. Here it is primary radical. It reacts with one more free radical. Therefore, it will convert into N-hexane. Between these two free radical carbon atoms, bond formation takes place. Therefore, we are getting N-hexane. Now, this molecule is treated with vanadium pentoxide. This is one of the most important for examination purpose. It is N-alkane having 6 carbon atom. N-alkane means all carbon atoms present in single chain. It is N-alkane. N-alkane on treatment with vanadium pentoxide at high temperature and pressure, it produces aromatic compound. This is aromatization reaction because we are getting aromatic compound, that is benzene. Here per 6 carbon atom, it is first carbon, it is 6th carbon atom. Between 1 and 6 bond formation takes place. First of all, we'll get 6-member ring. After that, dehydrogenation takes place and convert into benzene completely. Therefore, here what is the product? Here it is a benzene. This is compound P. It is benzene. It is only compound P. Now benzene is treated with concentrated sulfuric acid. This is example for sulfonation on benzene. It is electrophilic substitution reaction, and you must have some idea about sulfonation. Sulfonation is a reversible reaction and it has kinetic isotopic effect. What is kinetic isotopic effect? For example, if you take C6H6, if all are hydrogen atoms, then it participates in reaction at fastest rate. If it is a deuterium, then reaction becomes slower. If it is a tritium, then it becomes further slower. Matlab, there is kinetic isotopic effect. Now what will happen in this case? Here, hydrogen atom will be replaced by sulfonic acid group. It is benzene sulfonic acid. Now benzene sulfonic acid is treated with sodium hydroxide. Now what is this reaction? Now it is nucleophilic substitution on benzene ring. Benzene sulfonic acid treated with sodium hydroxide, then what will happen? We'll get phenol. This is also one of the most important conversion for examination purpose. Here it is benzene sulfonic acid. Benzene sulfonic acid treated with the sodium hydroxide at a high temperature. What will happen? In the first step, acid-base reaction takes place. Here it will remove H plus and react with one more sodium hydroxide. SO3 group take part in elimination in the form of Na2SO3. And on this carbon atom, OH group attacking takes place. Totally we are getting phenol. Of course, we can take salt also. That is not a problem. In examination, I can give phenol or I can give only sodium phenoxide also. What is the reason? It is a base. In examination, if they have given phenol and sodium phenoxide, then the best option is phenoxide. What is the reason? It is acid-base reaction. Because it is a base. Sodium hydroxide is a base. Phenol is soluble in sodium hydroxide. Therefore, it will convert into sodium phenoxide. Now, it is a phenol treated with chloroform in the presence of sodium hydroxide. This is one of the most important part. This is Reimer-Tiemann reaction. Chloroform देखने के बाद हमें एक reaction immediately याद आना चाहिए phenol के साथ. That is Reimer-Tiemann reaction. What will happen in Reimer-Tiemann reaction? On benzene, aldehyde group will attack at ortho and para position. What is the reason? OH is strongly activating group. It is ortho para directing group. Therefore, at ortho and para position, aldehyde group attacking takes place. Among ortho and para position, ortho product is major. What is the reason? Here, H bonding is possible. Stability increases. That's why we are getting ortho product. It is ortho hydroxybenzaldehyde. It is also called as salicylaldehyde. Now, this molecule is treated with silver oxide. Now, what is the reaction with the silver oxide? With the silver oxide, it is simply Tollens reagent. Silver oxide is just Tollens reagent. Actually, ammonical silver nitrate is ammonical silver nitrate. It is a Tollens reagent, but in examination, I can give AgNO3 ammonium hydroxide, or I can give silver amine complex. In a simple form, I can give silver oxide also. It is understandable. What will happen? It oxidizes aldehyde group into carboxylic acid. This is compound Q. What is happening here? Here aldehyde group undergoes oxidation, convert into carboxylic acid. Right, this is salicylic acid. Ortho-hydroxybenzoic acid, it is also called as salicylic acid. This is compound Q. Now this compound Q is treated with concentrated sulfuric acid and methyl alcohol. हाँ, हमें एक बात में 100% क्लैरिटी होना कंपलसरी. Carboxylic acid react with alcohol in presence of acid. Carboxylic acid react with alcohol in presence of acid. That reaction is called as Fischer esterification. This is one of the very, very famous reaction again. Carboxylic acid react with alcohol in presence of only acidic medium. यहाँ पर basic medium is not useful. What will happen? Carboxylic acid react with alcohol. It will convert into carboxylic acid ester. It is a Fischer esterification. What will happen in this case? Carboxylic acid react with alcohol. It will convert into carboxylic acid ester. It is methyl salicylate. What is happening here? Be careful. From carboxylic acid, OH group take part in elimination. from alcohol, H plus take part in elimination. Now this oxygen make a bond with this carbon. It will convert into carboxylic acid ester. This is methyl salicylate. Now, this is treated with acetyl chloride in the presence of pyridine. Now what is happening? Here it is acid halide. With acid halide, SN2H reaction takes place. What is SN2H reaction? It is nucleophilic substitution at acyl carbon. What will happen? Here phenol oxygen atom donate electron to this carbon atom. In the next step, from this carbon, Cl minus take part in elimination. Now, what is happening? Here, oxygen acylation takes place. What is happening here? It is oxygen atom. On this oxygen atom, C double bond O group is added. Therefore, it is oxygen acylation. It is acetyl salicylic acid. It is salicylic acid. CS3 C double bond O group is called as acetyl group. Therefore, it is acetyl salicylic acid. It is also called as aspirin. It is compound S. Now, this compound is treated with zinc and heating. Here it is one more very famous reaction. It is a phenol treated with zinc at a high temperature. What will happen? Reduction takes place. Metal, it is a reducing agent. Zinc react with this phenol. It remove this oxygen atom. Therefore, it will convert into benzene. That means phenolic OH group take part in elimination. Here per benzoic acid will remain same to same. This is compound T. Now, what is our question? What is the sum of heteroatoms and delocalized electrons present in compound Q, R, S, T? Now, in compound Q, how many heteroatoms are present? Here it is 1, 2, 3. Next one it is compound R. In compound Q, there are 3. In compound R, 1, 2, 3 heteroatoms are present again. And compound S, where is compound S? This is, here it is 1, 2, 3, 4 heteroatoms are present. In compound T, where is compound T? This is compound T. Here it is 2 heteroatoms. Therefore, here our answer is, here it is 12 heteroatoms. Sum of heteroatoms present in Q, R, S, T is 12. Next one is sum of delocalized lone pairs. Delocalized lone pairs. Be careful, not electrons. It is not electrons. It is, question is about delocalized lone pairs. We have to count only lone pairs which take part in resonance. Okay, now in Q, R, S, T again you have to count delocalized lone pairs. Here in case of Q, here it is one lone pair participate in resonance. Here oxygen atom carries 2 lone pair. Here also 1 lone pair participate in resonance. Totally 2 lone pairs participate in resonance. Therefore, delocalized lone pairs in Q is 2. In case of R, here also same to same. Here it is oxygen atom with 2 lone pair, but 1 lone pair participate in resonance here. Next one is on this oxygen, 2 lone pairs are present, but 1 lone pair only participate in resonance. Therefore, here also 2 lone pairs are present, which are involved in delocalization. Next one in S, here also, now be careful. Here oxygen atom carries 2 lone pairs, but only 1 lone pair participate in resonance. Now, some students may get confusion like 1 lone pair can participate in resonance with benzene, 1 lone pair can participate in resonance with this C double bond O, but it is absolutely wrong. What is the reason? Even though atom carries 2 or 3 or more number of lone pairs, only 1 lone pair participate in resonance. Therefore, here it is 1 lone pair and here also 1 lone pair participate in resonance. Therefore, in S also only 2 lone pairs participate in resonance. And what about T? Here it is only 1 lone pair participate in resonance from this oxygen atom. Therefore, now what is answer here? Here it is totally 7 lone pairs participate in resonance. Now the question is, what is the sum of heteroatoms and delocalized lone pairs present in QR and ST? There is 12 plus 9, totally 19. This is our answer. I think you have learned something from this. This is one of the most important conversion. My suggestion is, here you have to remember this conversion very carefully, because I have created the question using our past competitions papers from JEE Mains, Advanced, NEETs, AIMS, etc. And if you observe these papers, also you will also observe these kind of questions, only conversions. That's why be careful. And thank you for watching, and all the very best for your examinations. Thank you.